Carlo Rovelli, Helgoland, The World of Quantum Theory. Enter a mind-bending realm where particles exist as waves and cats can be both alive and dead. Welcome to the world of quantum theory. In a Helgoland, renowned physicist Carlo Rovelli guides you through this complex field, unraveling the fascinating mysteries that have puzzled scientists for over a century. From the groundbreaking work of physicists like Heisenberg, Bohr, and Schrödinger, to the strange phenomenon of quantum entanglement and the mind-bending implications of the relational interpretation of quantum physics, Rovelli reveals how this frontier of scientific thought continues to redefine our understanding of the universe and our place within it. Prepare to embark on a journey that will challenge your perceptions of reality and possibly even change the way you see the world.
The birth of quantum physics. In the early 20th century, physicists like Niels Bohr, Erwin Schrödinger, and Max Born sought to understand the mechanics of quantum leaps. They observed that electrons orbited the atom's nucleus at specific distances and leaped between orbits in quantifiable ways, but classical physics couldn't explain why. Heisenberg focused on what was observable, the frequency and amplitude of light, and reworked the laws of physics with matrices. Schrödinger saw electrons as electromagnetic waves, but this clashed with the observation that electrons existed as distinct particles. Max Born solved this paradox by proposing that wave calculations provided the probability of observations, while matrix calculations explained outcomes. This led to the realization that electrons existed as waves until observed, then collapsed into a point. The birth of quantum physics gave rise to a new set of questions, one of which being, why? The mystery of quantum superposition. Quantum superposition poses difficult questions about the nature of reality. The concept of Schrödinger's cat, a cat that is both asleep and awake, illustrates this central mystery of quantum physics. Scientists have demonstrated that superpositions actually occur, and there are competing interpretations for this strange reality. The many-worlds theory proposes an infinite number of timelines or worlds, while the hidden variables theory separates Schrödinger's wave from the quantum particle itself. Quantum Bayesianism or QBism, on the other hand, suggests that superpositions and Schrödinger's probabilities are just incomplete information. Each of these interpretations raises new questions, leaving scientists with a tantalizing mystery of the universe. The fluidity of the quantum world. The relational interpretation of quantum theory challenges the traditional understanding of observation and presents a world where everything is in flux. In this interpretation, any type of interaction is considered observation. All physical properties are relational and depend on circumstances. The universe is an endless network of relations that create properties, which give physical systems their characteristics. The relational interpretation destroys the distinction between the observer and the observed. All entities in the universe are both observed and an observer. Different relational events or frames of reference create different realities. This view challenges conventional thinking and provides a new understanding of the fluidity of the quantum world. Demystifying quantum entanglement. Quantum entanglement remains one of the most baffling concepts in physics, particularly when it comes to the seemingly magical connection between entangled photons. But the relational model offers some clues into what is really going on. According to this model, the properties of the photons only exist in relation to the observers, meaning that until mutual observation takes place, any comparison is meaningless. This may seem like a strange concept, but it ultimately helps to demystify the process of quantum entanglement and how the entangled photons are able to match each other across distances. Rather than a mysterious link, it is a web of relations connecting the events and giving them their properties. The interplay between philosophy and science. The world of science was dominated by a philosophical premise called mechanism, which was useful but limited. Ernst Mach suggested instead that science should focus on what's observable, the sensations that occur when elements interact. Mach's ideas inspired Heisenberg to investigate the actions of electrons, opening the door to quantum theory. According to Mach's conception of reality, physical objects aren't independent elements that mechanically interact, but rather, it's their interactions which produce the world. Observers also aren't separate from this system as they only know the world through the sensations of interactions. Mach's insight shows us the valuable interplay between science and philosophy and how contemporary philosophers can refine their ideas about reality by grappling with the latest scientific understandings. Quantum theory and the mind. The internet is filled with wild, misapplied quantum theories linking the strangeness of quantum physics to the big questions of life. But can it actually explain love and beauty? Not quite. However, using relational quantum theory to study the mind can reveal new paths for investigation. Philosophy generally offers three models for the mind: dualism, idealism, and naive materialism. Relational quantum theory argues that meaning arises through relevant relative information. For example, when a falling rock is spotted, the correlation between the external object and the internal state produces intentionality. Nonetheless, explaining the subjective experience of this phenomenon remains the hard problem of consciousness. Applying the concepts of relational quantum theory, especially considering relations and correlations, can help shed light on how the mind works. The world through quantum physics. Our perception of reality is not just about absorbing information and processing that sensory input. Our brains predict what we should see based on preconceived ideas, and discrepancies between expectation and reality are key to making sense of the external world. Studying quantum physics can provide new ways of looking at the world, where reality is an ongoing web of interactions, constantly updating and evolving. While science works on the same principles, the cycle of testing and refinement is much slower. Relational quantum physics presents a world where static entities do not exist, and our very identity is a product of correlations. Understanding this perspective may seem psychedelic, but it offers us a more accurate picture of reality.
Quantum theory has led us to reconsider long-held assumptions about the nature of reality, and Helgoland offers a captivating exploration of its most intriguing aspects. From Heisenberg's matrix calculations to Schrödinger's wave equations, and the relational model of the universe, physicist Carlo Rovelli opens up a universe of possibility, where everything is interconnected and in flux. Through fascinating and thought-provoking discussions of quantum theory, this book demonstrates that reality is even more complex, mysterious, and interwoven than previously imagined. Helgoland not only broadens our understanding of quantum physics but also highlights the profound influence of philosophical thought on scientific pursuits. By examining the reciprocal relationship between science and philosophy, Rovelli reminds us that even the most enigmatic scientific challenges can provide intriguing insights into the fundamental questions of life. So, take hold of your curiosity and dive headfirst into the enthralling world of quantum theory.